Hello, ladies and gentlemen. Welcome back. This is Mr. Ellering from Columbia Heights High School. Chapter 3 is all about solving systems of equations. We are skipping Chapter 3.1, which is on graphing them, where we see where the two lines cross each other. But we're going to go ahead and solve it in other ways with Chapter 3.2. We're going to take 2 days on this because there's two methods we're going to use. One is to solve using the substitution method, and then in the next video for day 2, we're going to look at the elimination method. All right, so what is the substitution method? What we're going to do is we're going to substitute an expression into one of the equations to solve for the variable. All right, let's get started. So here are the steps that we're going to follow. 1, get a variable by itself. Now, we want to do that in one step, okay? We want to pick the equation where it's easiest to get a variable by itself. Step 2, we're going to plug the expression it equals into the other equation. Step 3, we're going to do some algebra. We're going to solve for that variable. And then step 4, we're going to plug that answer back into an equation and solve for the other variable. All right, ladies and gentlemen, let us begin. So looking at these two equations, I think I'm going to go ahead and pick the top equation and solve for x because it only takes one step to solve for x. So let's see, if I take x plus 2y equals -2, I'm going to go ahead and subtract the 2y from both sides. And so now x equals, okay, I'm going to write it as -2y minus 2. Okay, remember you cannot combine things unless they are like terms. So you cannot combine the -2 and the -2y. All right, so step 1 is done. I have found one of the variables and got it by itself. All right, now what I'm going to do is I'm going to take and I'm going to plug the expression it equals into the other equation. So x equals this, ladies and gentlemen. So I'm going to go ahead and I'm going to plug that in for x right there. So let's see if I can color code this kind of. All right, so let's see, we've got 3. I'm going to replace the x with the -2y minus 2. I'm going to write this out first. All right, now I'm going to go ahead and I'm going to plug that in right here. Now remember, you have the power of rewind if you need to, or pause if I go too quick. All right, so I plugged it in. And now step 3, I have to solve for the variable y, because that's what's left in that problem. All right, so I have to distribute. So let's see. All right, I have to now combine like terms. Okay, the -6y and the 4y become -2y. I'm going to go ahead and keep going here. So now I'm going to add 6. All right, I'm going to go over here now and continue. So I've got -2y equals 12. And divide by the -2. And I find out that the y is a -6, ladies and gentlemen. Okay, now remember when we're solving a system of equations, okay, we have to have an ordered pair answer. We have to find x and y. All right, because we're wanting to know where do they cross each other on the graph. Okay, where do they cross each other on the graph? All right, so what we're going to do now is we're going to do step 4. We're going to plug that answer back into an equation and solve for the other variable. Well, ladies and gentlemen, let's make life easy, right? We want to make it as easy as possible. So what we're going to do is we're going to go ahead and take this y equals -6, and I'm going to go ahead and plug it into this equation because I want to know what x is, and x is already by itself on the left side. So I'm going to go ahead and plug in that negative 6 into y. So I have x equals negative 2. I'm going to replace the y with negative 6. All right, so I'm going to go ahead and put a negative 6 in there. And then I'm going to solve it. So x equals 12 minus 2. And I find out that that is 10. Cool. So x equals 10. I'm done. I now have my ordered pair solution, 10, negative 6. All right. Now, if I wanted to check that, I could real easily check that simply by using the calculator. Let me show you. All right, so let me demonstrate that with the calculator here. I can make sure that this is the right answer. So let me pull this calculator up, okay? And again, I have 10, negative 6, okay? I'm going to go back here to the original problem. All right, so here we go. So what I'm going to do is I'm going to replace the x. So I'm looking at this equation right here, ladies and gentlemen. Okay, this one right here that I put 2 stars by. All right, so I'm going to replace the x with a 10. So I'm going to go 10 plus 2. Now, the y value is, whoops, I missed the 2 here. Let me go back. And then I'm going to go times the negative 6, like that. Whoops, and then I missed a parenthesis. Well, come on. I got a new mouse, ladies and gentlemen, and it's not cooperating very well. All right, let me start that over. Sorry, folks. So we're going to go, let me use I'll just do it on the computer screen. 10 plus 2 times the negative 6, close it. Now that should equal negative 2. Oh, cool, it does. Okay, now I'm going to check the other equation. So I'm going to plug in the 10 and the negative 6 in for y. And I'm only going to show you this with this example. All right, so 3 times, again, 10, close it, plus 4 times the negative 6. And I should end up with a 6. And I do. All right, so that's how you can check your answers with the calculator. All right, let's do a few more examples here. All right, here we go. So in this problem, we are going to take this equation and get y by itself. Okay, because again, I want to do it in one step. So if I take the 2x plus y equals negative 2 and I get y by itself, I'm going to subtract the 2x. So now y equals, let me make that a little bit better looking y than that is right now. There we go. Y equals negative 2x minus 2. All right, now I'm going to, next step, I'm going to take that expression and I'm going to plug it into the other equation. Make sure you plug it into the other one. The biggest mistake that I've seen over the years is people are plugging it back into the problem, the equation they already used. All right, so here we go. So we've got the 5x plus the 3. I'm going to replace the y and then equals negative 8. All right, so I'm going to replace the y with the negative 2x minus 2. All right, it's algebra time, ladies and gentlemen. Algebra time. Here we go. So we've got 5x. Let's see, plus negative 6x minus 6, or plus negative 6, I guess I could just do that, or I could put minus 6 there, equals negative 8. All right, combining like terms. Let's see, we've got negative x plus negative 6 equals negative 8. And we're going to go ahead and add 6. All right, so I'm going to go over here now. So now I've got negative x equals negative 2. Now remember, ladies and gentlemen, you have the power of pause and rewind if I'm going too fast. Now I cannot leave a variable negative, so I'm going to go ahead and divide both sides by -1, and so x equals +2. All right, so there's part of my answer. X is 2. Now, I want to know what is the y value. Again, let's make life easy. We're going to take and plug in the 2 into this equation because look, I already have y by itself. So I'm just going to plug that into that one. All right, so I'm going to go down here and I'm going to do the work down here. So I have y equals -2. I'm going to replace the x with 2. All right, so let's see. I'm going to put a 2 right there. And if I solve that, ladies and gentlemen, I'm going to end up with, let's see, -2 times 2 is -4. Take away 2 more is -6. So y is -6. And there is my answer, folks. They cross each other at 2, -6. Again, if you didn't get that, rewind it, watch it again. Okay, I'm not going to show the check step this time to save a little bit of time. Let's move on. All right, so in this problem, let's take a look at what's going to go on here. All right, so I'm going to pick this equation and solve for x because again, I want life to be easy. I want as few steps as possible. So I'm going to get x by itself for that one. So let me rewrite it up here. All right, so I'm going to go ahead and I'm going to add the 3y to both sides. And so I find out that x equals 3y plus 7. All right, excellent. Now I'm going to take that expression and I'm going to plug it into the x of the other one. All right, so here we go. I'm going to take the 2. I'm going to replace the x. I've got -6y equals 12. All right, now I'm going to plug that in. So we got 3y plus 7. All right, algebra time, ladies and gentlemen, algebra time. Distribute, combine like terms, and so on. Here we go. Okay, I'm going to do it silently. Oh man, I see something weird going on here. Look, these things are going to cancel each other out, and I end up with 14 equals 12. What? 14 equals 12? That's some new math to me. Okay, well, you know, ladies and gentlemen, that is not possible. Okay? Not possible. $14 does not equal 12. So what does that mean? Okay, what does that mean? Anybody know? Anybody? All right, hopefully you went, oh, that means they have the same slope. Okay, because the variables cancel each other out. So that means, ladies and gentlemen, that these two lines, okay, there's no solution, first of all. Okay, let's put that down first. There's no solution. That means, ladies and gentlemen, they are parallel lines. Okay, they are parallel lines. They don't cross each other. They're parallel. There's no solution. Okay, so if you end up with two numbers that equal each other, but they're truly not equal, no solution. All right, ladies and gentlemen, we got one more example to go through, and then part 1 is done. Here we go. Last example for this. All right, have to show you this. I have to do one more example. All right, so again, I'm going to follow and make life easy. I'm going to take the second equation and solve for y because it only takes one step. All right, so when I do that, I end up with y equals -4x minus 2. Okay, I'm going to show fewer details with this one. All right, I'm going to take this expression and I'm going to plug it in here. Again, if I'm going way too fast, hit the pause button. All right, so I'm going to replace that y with negative 4x minus 2. All right, let's see what happens here, folks. I'm going to do my algebra. Whoops, that's not going to be a 6. That's going to be a minus 8x. And that's going to be a plus negative 4 or minus 4. All right, let's see. We get all right, I'm going to add 4. And let's see, I get negative 5x equals 15. So it looks like, ladies and gentlemen, x equals negative 3. All right, so there's part of my answer. Now I'm going to go ahead and plug that in up here. So when I plug that in, let's see, I have, sorry, this is kind of sloppy, y equals negative 4 times negative 3 minus 2. Well, that looks like that's positive 12 minus 2, so it looks like y is 10. I don't know if I did that right. Hold on here, let's see. All right. So, yeah, it is correct, ladies and gentlemen. That is a 10. So that gives us negative 310. All right, I'm going to take a minute and I'm going to go back. I need to talk about this really quick. I'm going to go back to this problem. So again, in this problem, we ended up with two numbers that don't equal each other. And when that happens again, you are going to end up with no solution, which means that they're parallel. But there is another scenario that I want to talk about. If you end up with something like this, okay, if you get like 10 equals 10, or you might get negative 3 equals negative 3, or you might get 7 equals 7. Okay, those are all true statements, right? Those are all true statements. The variable disappears, but they do equal each other. Those are true. Okay, well, what does that mean? Okay, that means, folks, that there are infinite solutions. So if you end up with something like that, that means infinite solutions. That means the two lines are on top of each other. Okay, basically they're the same line. Okay, they're on top of each other. Infinite solutions, because every point is true for both equations, because basically they're the same line, they're the same equation. All right, ladies and gentlemen, that's it. I went a little more than 15 minutes on that. I apologize. Hopefully part 2 will be a little bit shorter. All right, good luck.